Now we are going over the handouts I posted in Canvas for 6.1, which is solving systems of linear equations using row operations. So this is the problem I'm going to solve from page 3. This is example A. We are given a 2 by 2 matrix to solve. It's a system of equations with two equations with two variables. So, excuse me, the Gauss Jordan elimination method. First thing, we have to reduce the matrix into identity matrix, which is we have to make this one into 1, the second element to 0, and then this is already 1, so we don't have to worry about that. We have to make the negative 1, 0. So first, we have to reduce this, make it this one into 1, and the row operations are, we cannot subtract, like we can say like to make it 1, we have to divide by 2, so that brings the first row, first element to 1. So what I'm going to do is 1/2 row 1, and then it stays in row 1. So I'm going to make divide the first row by 2. So we get 1, 2, and 3. The second row remains the same. So that's what is given in the handout. Now we have to make the next one is we have to make this one 0. The second row, first element into 0. In order to do that, we can subtract row 1 and row 2. So the operation is given by, so you multiply the row 1 by -1 and add with row 2, and that result goes to R2. So when we do that, so you multiply the row 1 by -1, so that gives -1, -2, -3, and then you add with row 2. So when we add them, we get 0, -3, and 6. So that is what now second step. So you put this answer here, 0, -3, 6. The next step, we have to make this one into, now our job is to make it this -3 to 1. So in order to do that, we can divide by -3. So I'm going to write that step here. So that in order to do that, we are going to do -1/3 times R2, that goes to R2. So you keep the first row by itself. The second row is going to be 0, 1, -2. In the last step, we have to make this 2 into 0. So in order to do that, so we are going to do -2 R2 plus R1, that goes to R1. We're going to multiply the row 2 by -2 and add with 1. So we get 1, 0, 7, 0, 1, -2. So we got the identity matrix 1, 0, 0, 1. So we can write the solutions as, from this one, we get x equal to 7. From the second row, we get y equals -2. So the solution is 7, -2. So when the row operations are continued until only ones and zeros are in the coefficient matrix, that is called the reduced row echelon form. And this method is called the Gauss Jordan elimination. So now we are going to do, so we have additional examples as well. So let's do example B. So we are given as equations here. So let's first write the augmented matrix. So the augmented matrix means we have to write without the variables, only the coefficients. So we get -1, 2, and 2. We have to put the bar here, the line. That means these are constants. These are the variables. These are x, y, and y, and those are the constants. So now we have to make this first element into +1. So you just switch the sign. So multiply then row 1 by -1. So we get 1, -2. So you have to switch all the signs in row 1 to make it to make the -1 positive. Next, we are going to make the row 2. This first, we have to make the 4 into 0. So we can do the -4. We can multiply row 1 by -4 and add with row 2 and put the result in row 2. So we get 1, -2, -5, 0, 0, 26. And now if you look at the last row, I have 0, 0, 26. What that means is I'm getting 0 equals 26, which is not true. In that case, we don't have any solution for this system. You cannot have 0, 0 and some number that is not true. So this system is called inconsistent. If there is no solution, then the system is called inconsistent. And let's look at the next example we have. So let's first write the augmented matrix. So 4, -8, 12, -1, 2, -3. So as always, we have to make this 4 into 1. In order to do that, we can divide everything by 4. So that means what that means? Multiply row 1 by 1/4 and put the answer in row 1. So I get 1, -2, 3, and -1, 2, -3. Now we can see kind of, the same numbers with different signs. Now, let's see what's happened. So now I have to make this -1 into 0. We can do that by multiplying just add row 1 and row 2 and put the answer in row 2. So what do we get? 1, -2, let me go to the next page. So when we do that, we get 1, -2, 3, and the last row we are getting 0, 0, 0. And of course, from last row, we get 0 plus 0 equal to 0, which is true, because that implies 0 equal to 0. That is true. That means we are getting infinite solutions here. The system is consistent though. So in this case, we have to write y is any real number. And then the solution is going to be, so from the first one, we can say x minus 2y equal to 3. So x minus 2y equal to 3, and y is any real number. That means when you add 2y both sides, we get x equals 2y plus 3. So the solution I can write, the x is 2y plus 3, and y is any real number. So that means y is any real number. That means we will be getting infinite number of solution for this problem. The next is the possible outcomes for a 3x3 system of linear equations. So this is the final matrix. This is just an example how it's going to look. So the first one, we have the final matrix looks like this. 1, 0, 0, 9, 0, 1, 0, -7, 0, 0, 1, and 4. So if you take the first one, this is x, y, z. Let's take the first one. So then the work is x plus 0 plus 0 equal to 9. So that means x is 9. The next one is y is -7 and z is 4. So the solution we can write as 9, -7, and 4. The next one is 1, 0, 3, 8, 0, 1, -5, 6, 0, 0, 0. So if you look at this one, the last row is 0, 0, 0. Just like the previous example, we can write from this one, we can write x plus 3z equal to 8. And from the next one, we have so this gives us x equals -3z plus 8. And here y minus 5z equals 6. That means y is 5z plus 6. And the last one, of course, z is going to be any real number. Whenever you get 0 equals 0, this is how you write a solution. So finally, you write the solution, whatever you're getting for x, y, and z, that is, we are going to put it in the as in pair. So it's going to be -3z plus 8. This is x, and y is 5z plus 6, and z is just z. And the last one we have is 1, 0, -1, 5, 0, 1, 2, 3, 0, 0. So all these problems, we are just given the final matrix, and then you have to find the solution. So when you look at the last row, so the first one we can say x minus z is 5. The second one is y plus 2z equals 13. The third one we are getting 0 equals -4, which is not true. So in this case, there is no solution for this system. So the next example in page number 5, we have to solve using Gauss Jordan elimination. So it's going to be really a long problem because it's a 3x3 matrix. So this is the given system of equation. So let's first write the augmented matrix. So without variables, we have to write it down. So again, we have to make this into a reduced row echelon form, that is 1 0 0 0 1 0. So first thing, we already have 1, so we don't have to worry about that. So we have to make this 4 into 0. How we are going to do that? We can do -4. So you multiply row 1 by -4 and then add with row 2. So we get 1. So you write the first row as it is. So -4 or 1. So that means you multiply row 1 by -4. So it's going to be 8. And then -12. And then -44. And then you add with row 2. So we get 0, 10, -15, and -40. So that is what we are going to put here. Okay. And then oh. So the next one, we are going to make the third one 0 by multiplying row 3 and multiplying row 1 by -3. So we get 1, -2, 3, 11, 0, 10. This is what we get for row 2. And then we get 3. So we get -3 or 1. And then -3 times -2 is +6. And then -9, -33. And then you have to add with, you have to add with 3, 3, 3, -1, 4. So we get 0, 9, -10, and -29. So that is going to go to the last row. So we made the first one 1 0 0. The next one, our job is to make this one 0. Sorry, the second element has to be 1. So how do I do that? You divide by 10. So 1/10 of row 2 goes to row. So the row 1 is going to remain the same. So it's going to be 1 -3/2 and then -4. And then write the third row as it is. Okay, now this is already 1, so we don't have to worry about that. I have to make this one 0. So that's going to be -R2 plus R3 goes to R3. So 0, 1, -3 halves, -4. So -R2, so that means -0, -2, -9R2. So it's going to be 0, -9. And then -9R2 is going to be -27/2. And then -36. So it's going to be +36. And then you add these two. So we get 0, 0, 0, So 7/2 and then 7. Okay. Okay, so now we have to make the 7/2 in last row to 1. So you multiply row 3 by 2/7. You flip the numbers. You multiply by reciprocal. So we get 0, 0, 1, and 2. So we can stop here, or you can go further and then you can make this one into 1. So now we can make this one 0 by multiplying by 3/2. Plus R2 goes to R2. So we get 1, -2, 3, 11. So 0, 1, 0, -1, and 0, 0, 1, and 2. And then we can make this one 0 by doing 2R2 plus R1 goes to R1. So you write the last row 0, 1, 2. So it's going to be 1, then 2 minus 1 to 0, and then 2 is going to be just 3, and then 2R2 is -2, so it's going to be 9. And again, we can make the last one into, I'm going to put this one here. So it's going to be -3R3 plus R1 goes to R1. So it's going to be 1, 0, 0, and 3. Then 0, 1, 0, -1, 0, 0, 1, 2. So now we can get x equals 3, y equals -1, and z equals to 2. So the solution is 3, -1, and 2. Okay, so that's the end.